Okay, guys, so let's start. So today's topic is NAT-T. Before starting the Get VPN, I'll finish this topic. Okay, two small topics are pending, NAT-T and DPT. So these two topics first I'll finish and then I'll continue with the Get VPN. Now, the NAT-T. So what is NAT-T? NAT-T is all about, this is not NAT only, it's about NAT-T. Okay, NAT transversal. Okay, so this is all about NAT transversal. So see, up to now, we have configured a VPN, multiple VPNs and multiple time we have configured. So what was the concept earlier? Okay, like VPN we used to configure between the public IPs. Am I right, guys? Right? So VPN we used to configure always between the public IPs. Okay. On the both the sides, public IPs was there. Okay. So this was the, let's consider this is 11.1 and in between if we have ISP. So again, this is now 15.1. So reachability was there because first concept is reachability must be there. And after that, we can configure the VPN and all. But today, the concept is we have to configure the VPN between two devices. Okay, let's consider this is ASA as an edge device here. Behind that, this is one of my router, and the router is connected with ASA. After that, I have internet ISP over there, and this is my another site here. Okay, so this is site A, this is site B. So this is this connected with this. Okay, let's consider it could be ASA or whatever you want to use it, you can ASA and what else, router or whatever. Okay, so this is my ASA, this is a router, this is site A, and this is site B. This is site B here. Here IP I'm using as a 10.1.1.1.1. This IP I'm using here 16.1.1.1.1, and consider I'm using here 18.1.1.1 here. So earlier, just let me just open this one also. Earlier, we used to configure our VPN between this. Like this, between the public IPs. But today, we have to configure a VPN like this. Okay, same IPsec concept, I'll use it here. I'll use in a concept about same IPsec, same configuration, everything will remain same here. So what will be the peer on this side? The peer would be my 18.1.1.1.1. And guys, what would be the peer on this side?
10.1.1.1.
Exactly. But 10.1.1.1. So it means peer means the destination of my tunnel. Okay, the another end, or you can say another point, okay, of my tunnel here. But 10.1.1.1 is not routable over the ISP. Okay. So might be, let's consider if this side would start the communication and the first message itself was the 10.1.1.1. So here the packet would be dropped. Clear? Second solution, okay, I may do one thing. You can configure the VPN between this, then it's fine. But I'm thinking, no, I do not have to configure it like this. In CSAL and lab exam, there would be a task you have to configure the VPN like this here. So then what is the solution? The solution is NAT. The solution is NAT here. So I'm going to use here, or we have to use a static NAT here. So as per the static NAT, what I'll do, I'll use a static NAT. And as per static NAT 10.1.1.1, I'll use any public IP, let's say 150.1.1.1 here. And I'll configure on this. Okay. So as you know, when I'll configure a NAT here, that would work as a source NAT. And along with that, as a destination NAT. Okay. So as per the destination perspective, so if I have to ping after the NAT, if I have to ping to this device, so instead of the 10.1, I have to use what? 150.1.1.1, right? So now it means here, instead of this, what would be my peer? My peer would be 150.1.1. What would be the peer? The peer would be 150.1.1. This is the only difference. That's it. So in the configuration, first of all, we have to make sure there should be a reachability between both the devices. Okay, but this time in between both the devices, there should be reachability with the help of NATing. And after that, we have to configure a VPN. So by default, in normal IPsec, we use ASICAM port number 500. We have a UDP with port number 500. This is the normal one, regular one. But with NAT-T, we would use same UDP with port number 45. So this is the concept about NAT-T. That's it. So it would be detect automatically. We don't have to do anything, nothing. Just you have to understand here one thing. If now you are doing the configuration for a VPN tunnel, IPsec tunnel between any two devices, where on the one device direct we have a public IP, and on the another end, instead of the public IP, we have private IP. So it means if we have a private IP, it means before that we have one edge device, and on edge device you have to configure NATing for that. Yes, guys, is this clear? I hope this is clear now. So this is all about the lab about NAT. So we don't have that we don't have any specific concept. This is just a normal. Just if you know NAT and if you know IPsec, then it's easy for you. Okay. So I'll start with the practical for the same. So for that, let me start with EVNG would be better. Yeah, use EVNG. Do not use GNS. After this, tomorrow, once we'll start with the DPD. Okay, we'll see if I'll get the time today. I'll start it today. So tomorrow for DPD. Okay, so we have to use GNS3. Okay, because on EVNG we cannot capture its like output channel. So we have to use GNS. What happened? Okay. In yeah. This is guys ISP. This is your ISP. If you want to change its symbol, you can. This is kind of a cloud. I'll configure here. Okay, and just let me start the devices. So guys, how many of you have completed ASA? And who's already doing ASA with me on the weekend? Like, is there anyone who's not aware about ASA in this batch? Might if you have completed, if you are doing it, that's fine. Is there anyone who has not even started ASA? No one. Nice. Okay, only one day. Fine. Okay, fine. Anyone, could you try to speak? Well, I just check. I want to check my headphone. You guys are audible or not? Anyone?
Hello, sir.
Hello? Yes, sir.
Yeah, yes, yes, sir. You guys are audible. That's fine. I thought my headphone itself is not working. No. Okay. This is the one device. This is ASS simple, just only normal concept we have here. So interface IP, please. Okay, there's a no concept. So let it be start, guys. I have started the routers. Okay. And just let it be started. It will take 2 to 3 minutes. Meanwhile, ASA got started. So I'll configure ASA and I'll configure IP address here. So this is Z00 interface. The commands are same 0/0 IP address. This is 10 dot inside network is 10 dot 10 IP I have assigned. So I'll assign a dot 10 IP. I'll just explain about the IP addresses. So this is 10 network. I'll use a dot 1. Here I'll use dot 10 on this interface. Here again I'll use dot 10. ISP will use dot 100 on this interface and along with on this interface. And here again we'll use dot 1. So this is my private network itself, and this side we have a loop back. Okay. So from here, source IP in the ACL, it would be 10.1.1.0. Destination IP would be 2.2.2.0. And from this side, source would be 2.0 and destination would be 10.1.1.0/20. This is the interesting traffic. Yes, guess interface 0/0. IP address is 10.1.1.10/24. Okay. No share. Name if inside. Interface 0/1. IP address 11.1.1.1.10/24. No share. Name it outside. So show interface IP brief. Okay. Show name. Okay. So guys, this is the command on ASA. Okay, so this is I have configured IP addresses. This is my first interface and that is my another interface. So ASA does support the name-based concept. So this is the name I have assigned on my inside interface, and this is the name I on the outside interface. Okay, so this is just an interface IP I have assigned. Now, after that, I have to configure, because this is I'm going to be using as a default, as obviously this is my edge device. So as the edge device, I have to configure a default route towards ISP, and this is the ISP. So I'll configure default route into this direction. Who would be my next stop? 11 network, and here I'm going to be use dot 100 IP here. So 11.1.1.100 would be my next stop here. So I'll configure a default route, and the command is route outside default. You can go anywhere. Next stop is 11.1.1.100. So this is the command to configure default route on ASA. Guys, this is the ASA configuration. Sai and one more guy, like Shushil, I think you guys have not started ASA. So this is for you guys. I'll share this notepad. Okay. So meanwhile, you can at least copy and paste this ASA configuration and you can try to do your practical. Okay. Is this clear? How to configure IP address and default route on ASA. This is the same. Instead of using router, I'm using this. Or in case if you don't want to do it with ASA, you can use a normal router instead of ASA. Is this clear? Because in exam we have ASA, that's the reason I'm using the ASA concept. Clear? Okay.
Yes, sir.
Okay, or else you can replace your ASH with a router. Okay. So this is the we have configured on ASA. Now let's get back to the inside. This is my inside router, or you can see the host name is a site A, interface 0/0, IP address 10.1.1/24, no shut, IP route, and who's my gateway? As you know, ASA was my gateway. So 10.1.1.10. Okay. Ping with 10.1.1.10. Okay. Ping with 10.1.1.10. That's fine. Okay. After that, let's get back to this IO4 router. This is our site B. The host name, site B, interface 0/0, IP address 12.1.1.1/24. No share. IP route towards ISP. And 12 network I'm using 12.1.1.100 because we have decided ISP IP would be .100. Along with that interface loopback 0. This is IP address about 2.2.2.2 and /20. So show IP interface. Okay, so this is the configuration we have configured. Now let's get back to the ISP. So this is ISP here, and as on ISP, you can see here now. Host name is ISP. Interface 0/0, which is towards ASA. IP address would be 11.1.1.100/24. No share. Interface 0/1. IP address is about 12.1.1.100/24. No share. Do show IP interface. So we have configured both. So now just try to ping with your ASA with which is 11.1.1.10 there. Okay, ISP. So this is a ping with 11.1.1.1.10. I'm able to ping to our ASA and ping with 12.1.1.1.1, which is the site B. So ISP has a reachability for testing. Okay, guys, now is this clear? Okay. So now I have to use a NAT here because you can see this is a private IP, obviously, which is not a routable over the ISP. Okay, because why it's not a routable over the ISP? Because ISP doesn't have any routes towards the 10.1.1.0. Because obviously on ISP also we are using their routers. Okay, we have a separate track which is service provider track there, and in their routing table, the ISPs has not mentioned any kind of routes for the 10 network there, because the reason 10 is the private network here, and this is the reason that is not routable. So what we have to do, we have to make a reachability between this and this site. Okay, so but into that concept I have to use a NATing. So on an ASA, I'm going to be using NAT concept. But before that, you have to make sure there should be reachability between ASA and site B here. So from ASA, if I'll try to ping with 12.1.1.1, is that possible? That should be. You can see I'm able to ping with this. And if you would try to ping bit from site B, okay, to 11.1.1.10, that is also possible. So yes, we do have a reachability between what? We have a reachability between this and this. Yes, guys, is this clear or not? Any doubt, any questions in the reachability of ASA and site B? I hope all clear. Right.
Yes, sir.
So Now what we have to do, we have to establish a communication, direct communication between this. So for that, we have to use a NATing, and 10.1 I'm going to be convert into 100.1, or you can use a 150. So let's consider I'll use 150.1.1. So on ASA, I have to configure a NAT. So let me configure a NAT here. So guys, object network router 1, the host name is 10.1.1.1 NAT inside to outside static 150.1.1.1. So guys, this is a command for NAT on AS. Okay, so 10.1 we are converting into 150.1.1 here. So on ASF, I'll be back here and I'll check it. Show NAT, you can see it's updated, and show Exilate, and this is also. Yes, guys, I hope this is clear. Who has completed ASA earlier, right? Santosh and all other guys. One Santosh, Benita, these guys, they're already doing on the weekend, right, guys? I hope this is clear. Recently, we have finished all this concept, right? Yeah. Okay, so this is the NATing I have configured. Okay, so this is the static NAT. So now, with the help of static NAT, if I'll try to ping with 12.1.1.1.1, is this possible? Now you can see 12.1 ping is happening or not? No, it's not. Why? So first of all, see, the question is, do I have any route on a site A or not? Yes, I do have show IP route. If you would check it, I have a default route. So it means as per the default route, because from here, what is my source IP? Now see, just try to understand here. Guys, is there anyone in this batch right now who can tell me why I'm not able to ping? If you know, that's fine, or else then I'll explain. Why even I have configured NAT here, but still I'm not able to ping to this. Even there is reachability between this. I have configured a NAT. So as per that, data should goes to this one, and it should be converted into 150.1. And after that, so we have a reachability that should be communicate. Okay, but it's not happening. Is there anyone in this batch who can explain to why we are not able to ping?
Sir, from IS security level
traffic
to
one.
security level, traffic one.
ACL should be configured maybe.
ACL should be configured maybe. Okay. ACL. Okay, ACL. Okay, let's consider. Let's talk about the ACL there. Okay, so we need to add the route in now. Exactly. We need to add the one of the reason for that. Okay, correct. So, okay, guys. So let's talk about ACL here. So what is the ACL? So first of all, guys, NATing would happen, and after the NAT, because let's consider your request is going out here. For example, let's consider this is not 150. Okay, this is 11.1. This is 11. And this is 12. So now the solution here. The solution concept is this. What is the solution? The solution is, first of all, let's talk about NATing and ACL. As a ASA, so first there would be NAT and then there would be ACL, guys. So what is the concept here? Ki when your traffic is going out, the first concept is on ASA. Because ASA behavior is ki this is my inside and this is my outside here. Okay. So I can use multiple things here. I can use a ACL also. Okay, or I can use a fix-up protocol also. So let's consider I'll use a fix-up protocol in A. For example, right now, fix-up protocol, IC. Fix-up is done. And now if you would try to ping again here, that's not happening. The reason is, as a Pawan has mentioned, the route is not there on ISP. So he's correct. What is that route? From here, you can see the source IP and destination IP. So this is my source IP here. So here this is all about source IP and this is about destination IP. So what is the source IP? The source IP is here 10.1. Destination IP is 12.1. After that, netting is happening here. This is the netting. After NAT, what would be the source IP? It would be 150.1 and destination IP 12.1. The packets are reaching to this one. Okay, this is here. So right now this 12 is directly connected with this ISP because here we have a route table on ISP. This is the routing table of ISP, and in ISP route table we have two routes. Let's consider this interface is 0/0 and this is 0/1 we have. So this is a directly connected which one? 11.1.1.0/24 or interface 0/0 directly connected on 12.1.1.0/24, which is about 0/1. So now this router would check it. Do I have any routes for the 12 network? Yes, I do have. Directly connected on this interface, it would reach there. After that, when it's time to reply, so during the reply, so what would be the source IP? So if this is the header during the reply, this is the header during the reply. I'll mention it here. So this is a source IP, destination IP. So what is the source IP here? The source IP would be 12.1 and destination would be about 150.1 here. So here also we have a configured default route. Okay, so as per the default route, it can go anywhere. Okay, so after that, once it would be back on ISP would check it. Do I have any routes for 150? Answer is no, we do not have any routes for this. So what is the solution? As we can see, I'll show you the ISP route table here. This is the ISP, show IP route, and we can see we have only directly connected. So now I need to configure one static route, which is 150.1.1.0. Subnet mask is this, and next stop is 11.1.1.10. Because this is my personal ISP, correct? Because this is my right now you can say this is my EVNG console. This is my own ISP. So I have to add the route here. Why ISPs are charging to us? Because the reason they are managing their router, they have a team, they have added all the routes, okay? And that's the reason public IPs are routable here. So this is 150.1.0. I have added IP route static. If you would check it, it has been added. And now if you would try to ping, I'm able to ping. Clear, guys? From site A, I'm able to ping. Any doubt, any question in this ping now? I hope you got the solution for this. Okay, so solution was first. Okay, first it was the fix-up protocol. Fix-up protocol on ASA. This is fix-up protocol, and second is then a static route of ISP. Okay, so this was the solution for this. Now I have to this is if I'm able to ping from this side, it's fine. Now let's try to ping from the another side, which is what? Which is this side here. Now try to ping with, obviously with 10.1.1.1 not possible because that is the what? That is the private IP, right? So private IP obviously is not routable over the ISP. Okay. So now what we have to do is we have to try to ping with 150.1.1.1. But still this 150.1.1 is not happening. What is the reason, guys? Why this ping is not happening now? Even I am able to ping this router to this router. One side communication is there. One side I'm able to ping. From here to here, I'm able to ping. But from here to here, this is not happening. I'm talking about the same ping. You can see from here, I'm able to ping with this. And if you would check here, debug IP, packet, and if you would check it, even 150 IPs are, this is a reach packet reached, okay, as a 150.1. Okay, so when it's sending source IP 12.1, destination is 150, and here we have even default route, but still we are not able to ping. What is the reason for that? Okay, even we have a default route into this direction, right? We have a static routing now because I have configured the static routing 150.1.1.0/24 via 11.1.1.10 here. So we have a static route as well. Okay, Pawan has answered. What about other guys?
So traffic won't flow from security level of 0 to 100 in ASA.
Exactly. So what is the solution for that?
We have to configure an ACL.
ACL. Exactly. So let's configure ACL here. So in ACL, as you know, so ASA. So first it would happen NAT, and then it would be what? It would be ACL. So when your request would be back, as you know, this would be my reply, sorry. One, it would be back here. So first of all, natting would be there. It would untranslation would be there. So it would convert 150.1 first. The step number 1 here, it would convert 150.1.1.1. It's into private IP, which is 10.1. Correct. And after that, there would be an ACL. Right, guys? Correct. So then we have to configure ACL as a source IP 12.0 or 12.1 and destination IP as a 10.1. So let me configure an ACL here. Access list, ASA, permit, IP. The host is source is 12.1.1.1. Destination is 10.1.1.1. Access group ASA in interface outside. So on outside interface, I have enabled the ACL. I have mentioned who's my source. Guys, source I have mentioned my 12.1 here. Destination is 10.1, which is after natting, and IP means all kind of traffic here. And now if we would try, so let's get back to the ASA. I have configured it. If I'll be back now, and if I'll try to ping, and if you would be checked here, okay, in debug IP packet, this is happening, okay, it's fine. The packet exactly is reaching, yes, it's reaching. Okay, so you can see source IP 10.1 and destination 12. So this is the sending the packet. So when it has received the packet, source as a 12.1, destination 10. Clear, guys? Is this clear? I hope now it's all clear. So right now from another side also we have a reachability with 150.1.1.1. Okay, with whom? With the desk consent. Clear? But instead ASA, instead of using like I'll be back here with the ASA. And if I'll remove, this is access list, I have removed it to show access list. It's not there. And now if you would try to ping now, that's not possible because the reason I have removed the access list here. Okay. So in this scenario now, what we have to do it, instead of using IP, in CSAL app exam, you have to allow the specific traffic. So I have to allow extended permit. Instead of IP, use ICMP. Host is 12.1.1.1, or you can use whole network also, which is 12.0 or whatever. Let's consider I'll use a host 12.1.1.1 and destination as a 10.1.1. This is for specific device. Otherwise, you can define a network also. And as a echo request, because from outside it would be echo request here. Access group ASA in interface outside. And now if you would try, as you can see, that's possible. Okay, so show access list, this is fine. Hit counts are getting increased by 5. Okay, guys. So now after this, so right now I have a reachability. We just made a reachability between this device and this device with the help of NATing and ACLs and all. What we have to do it now, we have to on this ASA, as you know, right now I have just allowed it ICMP traffic, which is the specific traffic. In the previously I have used IP. IP means which is all about ICMP, UDP, TCP, all kind of traffic there. So right, but we don't have to use IP there. We have to use ICMP, which is the specific traffic. Now in the same ACL, I have to add 2 more entries. Why 2 more entries? Because see, this is, let's consider I'll configure IPsec on between both the sites. Here I'll define my peer as a 12.1. Here I have to define a peer as a 150.1.1.1. So when they would start, because let's consider this device would initiate the message like packet. This is the message number 1. Message 1 would reach there, but when the time for the message 2, so message 2 would be blocked on this side. The reason because message 2 is coming from 0 to 100, and as you know, that is not allowed it by default. Okay, so here we have to allow UDP traffic. Again, for UDP, we have to allow ISACAM packet here. Okay, where the source would be this device and destination would be your this device. And this is I'm talking about ACL here. So you know, first there would be NATing and after there would be ACL. So ACL you have to define for the private network. Yes, guys, is this clear or not? Why we have to allow the ISACAM? The first try to understand why we have to allow the ISACAM here. That concept is clear or not? Only, okay. Now, so we have to allow 2 kind of ISACAM here. What is the reason for that? 2 kind of ISACAM means till now, so we have just heard about 1 only. But as you know, as I have mentioned for ISACAM, there would be 2 port number. One is for the 500 and second is 4500. Because for the first 4 packet, the UDP port number would be your 500. And after that, 5th packet onwards, okay, your UDP port number would be 45. Is that clear? 5th packet onwards, UDP 4500 would be there. So until unless if your first 4 packet won't be able to exchange, so obviously we cannot expect anything about the 5th packet, because if first packet itself is getting rejected and that is not able to exchange, so how you can even switch to the second packet? So even if we are not able to switch to the second packet, so how we can think about the 5th packet here? Okay, so that's the reason right now we have to allow, or we have to enter 2 more ACL here with the same name. Okay, so UDP, this is whatever the source and destination. This is ISACAM by default port number 500, and then I have to mention 4500 for the NAT-T, because 4500 is for the NAT-T here. So same here now, access list, ASA, extended, permit about UDP. The host is 12.1.1.1.1. Destination would be 10.1.1.1, and which is equals to, okay, ISACAM. This is 1, and second is port number 45. UDP. So show access list. I have added 2 more entries. Okay, show accelerate. Okay, that is. Yes, guys, is this clear? I hope all clear now. 12.1, this is 10.1 equal to Isaac Camp. Okay, it's fine. And this is 45. Absolutely fine. So now we have to start with the configuration of IPsec here. So now let's start with on this side here. Let's try to ping with 12.1.1.1. Am I able to ping with 12.1 or not? I'm able to ping with 12.1. Easy. Okay. And from outside also, do I have a reachability with 150.1? It is. So all clear, everything is fine. Now let's start with the configuration. Crypto Isaac Camp, policy 10, encryption 3 dash, hashing MD5, group 2, authentication, pre-share. Okay, group 2 MD5. This is, let me just configure on the another side as well. The same configuration. Crypto Isaac Camp, policy 10, encryption 3 dash, hashing MD5, group 2, authentication, pre-share. Now, after that, we have to configure here key now, crypto as a camp key. Okay. Key is what I'm going to be used Cisco. Address is what with 12.1.1.1.1. Okay. Crypto IPsec, transform set, T set, ESP, 3 dash, ESP, MD5. Exit. Okay. So this is a ditto copy and paste. Let me copy and let me paste on the another side. Crypto as a camp key. Key is Cisco. Address is 150.1.1. Up to here, we have configured. Everything is fine. Now access list here. Access list 101 permit IP. Okay. So who's the source? Which traffic I just want to allow here? Okay, IP here from 10.1.1.0 wildcard mask and then 2.2.2.0 wildcard mask. So this is the access list. Okay. After that, crypto map, IMAP 10, IPsec as a camp. Set peer 12.1.1.1 is my peer. Set transform set. It's all about T set here. Set transform set, then match address 101. Okay. Interface 0/0 and crypto map name is IMAP as a campus. Okay, just let me enable the capture here once. All fine here. Now this is okay. Now let's get back to this. Key and this is I have transform set also we have configured. Yes. Now access list 101 permit IP 2.2.2.0 wildcard mask 10.1. So this is about what? This ACL is about what would be ACL here? Because this time we are sending the traffic for 150, right? So shall I send it for the 10 or 150? Yes, guys, what do you think? Shall I configure here the traffic for the 10 or 150 here? $150. So the host is, we'll define a host as a, or just any subnet, I'll define 150.1.1.0. Welcome. Okay. And that subnet itself I have defined. Okay. After this, now crypto map IMAP 10 IPsec ISACAMP. Set peer, who would be peer 150.1.1.1. Set transform set tset match address 101 interface 0/0 crypto map name is IMAP. This is done, it's on. And now from here, now try to ping with 2.2.2.2. ISP doesn't have any route for the 2.2 because I'm not using any NAT here, so I have to go back to the this route here. IP route 2.2.2.0 subnet mask as a next hop 11.1.12.12.1. Now let's try here. Debug IP packet. See the packets are able to reach or not. Packets are reaching here. This is fine. And even when we are sending, it's a quick mode. We are sending, we are not getting a reply from there. Okay. Packets are reaching and even it's saying this is IP packet. Or this feature is also not. We erase it for 2.2 interface. We apply the eSelf for the interface. Where on the interface for 2.2? No, that is not required because first of all, that ISACAMP tunnel would be established between 12 and this one, right? After that, 2 would comes in the role. Well, let's say I have started a ping from here, okay, and even fixer protocol is enabled for that. That is just a reply because that's the reason I have pinged from inside first, not from outside. Because what I can see here, okay, this device is just receiving. It's not able to send. It's not sending it. Source IP 12.1, destination is 150. Oh, it's sending also the full packet here. This is fine as a destination IP 150.1. Destination is 150. And let me just check it on. Flow route. We have default route for static routing for 150. Then is there any problem with the ASA? Show access list. These hit counts, this is not getting increased. I think somewhere I have made a mistake into this. I think so. UDP host is 12.1. Because this hit count is getting increased. This is not. This is the guys. Do you remember this is the same kind of issue what we have faced during ASA class also once. One ACL was working, another ACL hit counts was not increasing. This is that same issues we are facing here again. Because if you would check it out, and if I'll go to the ISP, if I'll enable debug IP packet. Okay, this is so passing through this. Is sending the packet. This is fine. Source IP is here 12.1. Destination is 150. And encapsulation fee, everything is fine here. Mhm. Or I have to just restart the ASA. This is sending the packet here. This side, this is already sending the packet. So, but ISP is fine on ASA. Let me just restart the ASA once. Let me just save the configuration here, right? And now just let me reload the device. Well, sometime happens, okay. We have seen these kind of issues in ASA class also. So let me just restart the device here. Okay, I have used, see, this is NAT on GNS. I think I had to use it. I had on GNS. This side I have used for the 10 network. Here I have used AC for this 10. Okay, I'll try to use for the 10 also. Because here, as you can see in the command, here I have mentioned, not this one. First of all, guys, let me check it out. This is not on GNS. This is here on GNS only I have mentioned, not on EVNG. I think so. Okay. This is the 150 I have added, so I'll just make it 10 once. Let me do some changes because as I can see here, I have mentioned for this GNS. Wait for this. Let it be start. Okay, guys, now let me take it out. Show access list here. All clear. Let me just try to ping with 12.1.1.1. That's fine. The ACL is working. Now why ACL hit counts are not increasing? Okay, and from outside, if I'll try to ping wedge 150.1.1.1, able to ping, hit count is getting. So guys, there is a no problem with your ACL. The reason because everything is working because the upper one. So you can see earlier this ACL is working. It means NAT first natting would happen, then ACL. So this ACL is perfect. There's no problem with the ACL. UDP extended AS, everything I'm fine. This is okay. And now from here, try to ping wedge 2.2.2.2. Let's see. This is not happening. Let me do one small change here. Interface 0/0. Let me disable this. No match address 101. I have removed it. So now I have configured access list. Let me remove that access list. I have removed it. Access list 101 permit IP 2.2.2.0 10.1.1.0 wildcard mask. Now crypto map IMAP 10 IPsec as a cam. Okay. And here match address 101. Set PSO is already there, which is 150.1.1.1, and set transform set T set is already there. The page was /0 map IMAP here. And now if I'll be back on this, it worked now. I'll check it. Okay, but before this, just verification is here. Now UDP port number 500. You can see there is no such as changes in the its you can see what we call in the header, which is the 500. So this is the 500 here in the first one. Second is also 500. Third is also 500. And now fourth is also 500. And fifth packet onwards is 4500. This output is clear or not? This is guys. Is this clear?
Yes, sir.
Right, clear?
Yes, sir.
Yeah. So now ACL. Okay, the question is, Amit, ki why this ACL is not working? Now I just got it. See here. The concept is here. The concept is on this one. Show access list. Remember one thing. One concept is show access list here. And along with that, if you would check it, who is my peer guys from here? Who is my peer? 150.1.1.1, right? And what was my destination into this I was using here? Earlier I was using 150.1.1.0. So we have one concept actually in IPsec. In IPsec, the concept is ki whatever the peer IP are you using it. The peer IP means with that device, I'm going to be establish one tunnel over there, right? That tunnel I'm going to be configured with that. So in a source IP and destination IP in the ACL, you cannot use the same network again. This is the concept. Okay, so what's the problem? What I was using the peer is also from the 150 and destination is also from this was also from the 150. That's the reason it was not happening last time. But the moment when I have changed it and I made it as a what? 10. Okay, then it started working. Are you getting my point here? Okay, because on you cannot use, okay, same concept. The peer IP cannot, okay, or peer network cannot be the part of the ACL. In case if you are using, let's come, question is, Kiamit, what if I want to use it? So then you have to go with the concept about route-based ACL. Okay, where you can use up from the network from the same interface with the help of the routing protocol. So in policy-based VPN, we have a concept, okay, like whatever the peer you are using it, that same network, because IP, okay, the same network cannot be the part of the ACL, because ACL is all about always private IPs, not about the public. This is the reason that was not working. Now I got it. Yes, guys, is this clear? Because ACL is always about the private networks, not about the public. So that is the mistake what I was doing it, because 150 is the public one and the same network I was using in the ACL. That's the reason that was not working. Clear? Yes, guys, any doubt, any questions, anyone? So this is the concept about the NAT-T. In interview, how they would ask you, recently some student, they have appeared for the checkpoint and Barracuda. So in the Barracuda, they have asked about the port number 4500. They have asked ki, when we were doing the monitoring in the network, so we were getting the some packets of the at port number 45 as a ISA camp. So what does it mean here? So that time you have to explain the concept about NAT-T here. So when you would start explaining about the NAT-T, and obviously you would start the talking about the like message exchange. So that time you have to mention one more thing. Okay, it would detect the 4500 port number from the 5th packet onwards, not from the first packet. That's the reason I have mentioned an ACL here with the port number 500 and 4500. Because this 500 is for the first 4 packet and this is 5th through 9th packet. Yes, guys, I hope this is clear now.
Yes, sir. Yes, sir.
Okay. So this is all about NAT. Okay. So next topic, I'm starting here as a DPD. At least theory, I'll finish it today. Okay. And tomorrow we'll start about the practical. Okay. And tomorrow practical, we have to do it on GNS3. I'll not use EVNG because in EVNG, we cannot get any output about the DPD. Okay. DPD is what? DPD, some idea I'll give you now. Okay, remain 10 to 10 minutes. I'll explain it now, and then remaining part we'll talk about tomorrow. Guys, you know EIGRP? Right? In EIGRP, we have a concept. Okay, let's consider if EIGRP is there. Let's consider these are the two devices, and they're both the neighbor to each other. Okay, so this is about 11.1, and this is 11.2. Here my EIGRP neighbor is 11.2, and here my EIGRP neighbor is 11.1. Who's my neighbor? 11.1. So guys, you know, when we talk about EIGRP, so after every, I think 3 seconds or after 5 seconds, what is the timer for the hello timer in EIGRP, guys? 5 seconds. After every 5 seconds, both the devices, they would exchange hello messages. What they would do? They would exchange the hello messages. Okay. Why do we need hello messages? Why do we need hello messages? Keep alive. Yes, this is kind of keep alive, like to maintain the neighborship here, right? In case if they are not able to, let's consider this device is down and not able to send any like messages here. So this device would wait for the 15 seconds. It's not receiving any hello message. It would declare it as a what? Again, that this neighbor is dead or this neighbor is expired or whatever. The question is, what about in IPsec? What about an IPsec? Let's consider this is my IPsec I have configured. Okay. As you know, the data, the phase 2, the tunnel to the data tunnel would be up for the how long, guys? Data tunnel is up for how long? Please tell me. The data tunnel would be long for how long? Like it would be for 3600 seconds, right? Let's consider right now I have exchanged some data. Okay, as you know, this data is always in the encrypted and hashed because this is all about what? Encrypted, encrypted plus hashed here. Let's consider it's been now 40 minutes. Tunnel is idle. Okay, we have not exchanged. We have not exchanged any data. Okay, after 40 minutes, I want to exchange some data here. But I just want to know, I don't, because see, guys, in IPsec, we have not discussed anything about the keep alive messages or hello messages there, right? Because in IPsec also, we have the concept about IPsec keep alive messages. By default, it's see. The first question, why do we need this kind of messages? Because right now, see, after 40 minutes, I'm sending some important data, but I'm not sure as a site A, as a sender, I'm not sure the site B is still alive or not. Okay, might be I'll send the data, but site B is down. So the whole data would be what? That would be dropped. Okay, this is unnecessary. I'm using the bandwidth. Unnecessary, I'm sending the packets over here because even if my site, like my another site is still down, okay, because here they are not exchanging any IP, they any keep alive messages. Okay, because if tunnel would be up for the 1 hour, it would be 1 hour only. After 1 hour, they would negotiate again. And might be during the second negotiation, they would be get to know, ki, oh shit, what happened? Another site is not replying and that site is down. Clear, guys? Okay. The question is, ki Amit, why, like, first of all, why we need a keep alive? The keep alive, I need it because for the last 40 minutes, my site, my both the, like, this tunnel was idle. Okay, we were not exchanging any data. So before sending the data, in case if we are already exchanging the hello messages, in case if we have the hello message concept here, so that is that would help to this site to send the data and to just identify ki yes, the another site is already in the up state. If they are exchanging the hello messages like an EIGRP. Okay, like keep on changing like hello messages after every 5 seconds there. So, but here we do not have any concept about keep alive messages by default. The reason, Amit, can we enable that? Yes, we can enable, okay, IPsec keep alive messages. We have also timer here like a 5 seconds. Okay, we can exchange. So after every 5 seconds, they would exchange what? They would exchange keep alive messages. So guys, is this keep alive messages are good or not for us? Is this good or like, is this in a what? So guys, tell me, do you think we need a keep alive message here? IPsec keep alive messages here? Because my tunnel is idle for the last 40 minutes and we have not exchanged any data. But after that, when I'm sending the data on the another side, the site like tunnel is already down. So I'm sending my data, but another side is already down here. So whenever I'm sending the data, another side is not able to receive. So that's the reason wastage of bandwidth. Okay, so do you think we need any IPsec like keep alive messages here? Do you think we need it here? Why we don't need, Santosh? Let's consider because if down the data down. No, you are not. I think I'm not able to. I think I'm only not able to explain. So let's consider, for example, my keep alive messages are enabled here. We have IPsec keep alive messages, which is enabled by default, for example. Okay, so now see, right now, I'm not exchanging any data. It's fine. After that, it's idle for the 40 minutes. And after that, I'm sending the data. But during the 40 minutes, both the sides, they have exchanged multiple keep alive messages with each other. And because of these keep alive messages, now both the sides knows that yes, side B is up and this is side A is up here. After that, side B want to send some data. This is good. And now send the data here. Clear, guys? This is clear or not? The case number one. If it's enabled. So here it's helping us, right? Scenario number two. Scenario number two, what if it's disabled? Disable means it's not enabled here, it's disabled. This is now 40 minutes. Tunnel is idle. Right now, no idea about side B, if the side B tunnel is up or not on the another side, but I'm sending the data. So I have a sent, let's consider the file of 1 TB here. 1 TB file I'm sending, and but another side tunnel is down, not able to receive. So it means I'm doing the wastage of my bandwidth. So unnecessary, I'm using how much like bandwidth over there? 1 TB. Because I'm thinking why I'm sending data, because right now I do not have any idea about what about the another side, is this up or not, and unnecessarily I'm sending the data. So this is the word wasted of bandwidth. So then I'm thinking why IPsec is not the why there is a no concept about keep alive messages like in EIGRP. Okay, because if we have a concept about EIGRP like keep alive messages, so that is the best option, because at least before sending the data, I would be like confident that yes, another site is already up here, and then easily I can send my data. Okay, yes, guys, this scenario is clear or not? What is the disadvantage if this is disabled, right? Because if disabled means unnecessary you're sending the data. Let's consider continuously and just without asking you, okay, I'm just continuously delivering the lecture from the one side, and I'm not asking guys, is this clear or not? Are you there or not? So that is what in between the session, again and again, I'm asking guys, is this clear or not? Waiting for the acknowledgement. So means that is kind of key hello messages here. But if I'm not doing all this and just continuously I'm sending like I'm delivering the lecture here one side, and after 1 hour I'll just go to know shit if the students were not online. Okay, there was a communication problem. So again, I have to repeat the same things here. So this is the disadvantage of this here. So this is means overall in IPsec, if we have IPsec keep alive messages, that is the one of the best option. Right or not, guys?
Yes, sir.
So having IPsec keep alive is good option till now. So question number is then, if it's a good option, then why IPsec keep alive messages are disabled by default? Yeah. So don't you think Cisco also knows about all this? Yeah, it would be good. The reason is because for the next 40 minutes, if tunnel is idle, Okay, so then what is there? Obviously, during the 40 minutes and after every 5 seconds, if you are exchanging the date, like the keep alive, let's consider after every 5 seconds, you are sending the keep alive here. So in a minute, you are sending 12 messages, and into 40, 480 keep alive, we will exchange. Okay, in 40 minutes between site A and site. Okay, which is encrypted plus hash. Yes, guys, is this clear or not? So how many packets and how many messages we have exchanged between both the sides? 480. Okay, don't you think that this is unnecessary packets we are sending here? The question is, Amit, how you can say this is unnecessary? I'm saying this unnecessary because unnecessary encryption and hashing is not happening. Okay, but Amit, you are saying that this is unnecessary. So what about this? Because even it's helping us, right? It's helping into this scenario. I'm saying ki, okay, you are talking about the case where you are not exchanging the data, for example. But if I'm saying ki, if we are exchanging the data also, but along with that, like EIGRP, we are exchanging what? Keep alive messages also. Are you getting my point, guys? Ki, if this is the good scenario is what? If tunnel is idle, means no data exchange, then keep alive is good. Okay, but the case number 2, we are exchanging the data, and along with that we are exchanging So do you think, you guys, in second scenario, we need any kind of keep alive messages? Because see, I'm just asking you something, you are just continuously replying, the conversation is going on, but in between, again and again, I'm asking, hi guys, are you there? After every second, after every 5 seconds, I'm asking, guys, are you there? Hi guys, are you there or not? So this is kind of irritating or not, right? This is kind of irritating things and unnecessary messages and unnecessary thing I'm asking you. Okay, I'll be also irritated, and as a listener, you also would be irritated of the that thinking why Amit is asking again and again, hi, are you there or not? If we are already communicating, you are asking something, you are, let's consider you have a question and that would take 15 seconds for you, but in between, like after every seconds, I'm asking, are you there? Are you there? Are you there or not? So that is the kind of unnecessary concepts here. And in EIGRP, that was okay, because EIGRP hello messages was not encrypted, there was no hashing. But in IPsec, we have one extra concept here, ki that is even messages, hello messages are what? That is also encrypted and hashed. So unnecessary encryption on a site A and unnecessary decryption on the site B. Then same site B would send a hello, then unnecessary encryption on that side and unnecessary decryption on the site A. The clear or not? So when we are using a keep alive messages, I have explained in the both the scenarios. As an advantage also, if tunnel is idle, after that I want to exchange some data. So if I'm not using any keep alive messages, so and if tunnel is down, so I do not have any idea. And if I'm sending a file of 1 TB, that is the unnecessary bandwidth I'm using it. Correct? I'm sending, why I'm sending if site is already down. Okay. The second option is what? Okay, I'm already exchanging the data, and why unnecessary in between you are sending the keep alive. So both the concepts we have. So the keep alive has a kind of advantage also, and there is a kind of disadvantage also. Okay, so this is the reason Cisco made a concept about ki do one thing. This is by default disabled. Okay, so as a user, if you need it, you can. And if you don't need it, if you think, yeah, this is a good, let's consider like here in this class, for example, Santosh is saying, no, Amit, this IPsec keep alive is good. Because as per his scenario, he is like exchanging the data after every 20 seconds or 15 minutes. Okay, so before sending the data, he just want to be sure that yes, another side is alive or not. Another side, Pawan is there. And as per him, he is continuously exchanging the data. So he is thinking, Amit, why unnecessarily these keep alive messages are there? Because in a 1 hour, we would exchange up to, because in a 1 minute, we would exchange 12 messages. And into overall what? In a 1 hour, 12 into 60. 720 messages. Okay, so 720 encryption would happen on site A and site B. So here 720 encryption. This is the one, this is here. You can see 720 encryption here. Mm-hmm. 720 encryption, then 720 decryption. Another side 720 encryption and 720 decryption. So Santosh is saying, as per his scenario, no, Amit, this is good. But Pawan is saying, no, Amit, I do not need it, because continuously, if I'm already exchanging the data, Amit, if already communication is going on between you and me, so why we are asking to each other, hi, are you there? Hi, are you there or not? Okay. So, and even EIGRP, okay, EIGRP and OSPF, they have that scenario, that's fine. But in the context of IPsec, these packets are also encrypted. Additional, the CPU utilization would be high actually. So this is the timer where I'm using it 5 seconds. We can modify the timer. Let's consider IPsec keep alive messages timer is 3 seconds. Then again, we have more number of the messages, high number of the messages. Clear? Okay. So sometimes it's an advantage, sometimes it's a disadvantage. So that is scenario to scenario. So this is good for, as Santosh is saying, it's good, but Pawan is saying, okay, not good into myself. Is this clear or not? Yes, guys. But here now, Benita is asking, ki, Amit, is there any solution in between? Ki where Santosh requirement and the Pawan requirement both would be like satisfied, like we would be able to achieve both the things. Ki whenever we need a keep alive, what is the overall concept about Santosh? Santosh is like, there, just 1 second. So now Benita is asking something, some solution in between. In between means Santosh is saying ki I'll exchange the data, or I'm exchanging the data after 15 minutes, and before exchanging the data, with data is about 1 TB file, before sending the file, I just want to be sure ki yes, tunnel is up between both the sides. So Pawan is saying ki unnecessary messages, I do not want it. Okay. So this is kind of on demand. So the question is there any solution in between? Yes, we do have a solution, and the solution is known as IPsec DPD concept. Dead peer detection on link. Is this clear? The solution is what in between? Guys, first of all, before solution, the problem is clear or not? Why Santosh is saying it's good and why Pawan is saying it's not good? Yes, guys, this concept is clear or not? Is there anyone right now who has a doubt and problem with the Santosh and Pawan's output? This one, I hope it's clear. Now, the second is saying in between we need a solution, and what is the solution? The solution is DPD here, dead peer detection. Okay, so this concept is, guys, key. Let's consider. I'll give you just an idea right now. Otherwise, tomorrow we'll talk about it, because practical also I have to show you along with this. DPD is saying what? Okay, your session is idle for 10 minutes. Okay, or let's consider it's idle for the 15 minutes. After 15 minutes, you want to send the data. Okay, so but here right now, this is my data here. Data is ready. Okay, so but I'm not sure. Okay, I'm not sure here the site B is up or not. So I just want to know. So I'm what? Right now, I'm missing keep alive. Okay. Okay, I'm missing what? I'm missing the keep alive. So I have a solution. The solution is what? Ki DPD is what? On demand. DPD means what? Before sending the data. Before sending the data. This is idle, it's idle for the 15 minutes, and now I just want to send the data here. But before sending the data, I'll send one specific packet here, which is the keep alive only, but that is on demand. It would send, this site would reply, and when you would get the reply, you would be okay, yes, the site is on here. The site is up, another site is up. Only one keep alive when you need it here. This is kind of stuff. Let's consider this is you and your friend, and you have made a plan ki, okay, tomorrow I'll come your home. So this is today's plan here. But after that, for the next 12 hours, there is no communication between you and your friend. And now you just want to start it. Ki, okay, I'll start, and in another 10 minutes, I'll reach to my friend house. But before starting from your home, you would just call him ki, hey, I'm just coming. Are you there now at home? So this is just what? This is on demand. Clear? Yesterday, 8 p.m. you have decided, okay, tomorrow morning, 9 a.m. I'll come at your home for the breakfast. Okay. So, but before leaving to your home, okay, what you are doing it, okay, I'll do one thing. Before leaving, I'll just call him. He's at home or not. Might be he has left for some work, or might be, okay, he's still sleeping or something. At least I'll call him, I'll inform, and along with that, I'll ask you, okay, I'm coming. Okay, are you there or not? So this is what? On demand. Clear or not? So this is same. Before sending the data, we are just sending one particular message that is same keep alive only, but that keep alive is known as DPD, dead peer detection. I just want to know why the another peer is dead or not. So dead peer, another side is my peer detection. I just want to know the site is dead, my peer is dead or not. Okay, so this concept is known. So here we have both the problem has been solved. Like now, Santosh is also happy. The Santosh intention was ki before sending the data, I just wanted to know that my another side is dead or not. So now the problem got solved. And here Pawan is also happy ki okay, instead of sending multiple this one, because let's consider 60 minutes is the timer for my tunnel 2, and in between the session was not idle. Okay, continuously I'm sending the data. So now it's absolutely fine. No need to exchange your keep alive here. So this is Pawan is also happy and Santosh is also happy because both the guys got the solution. So Benita, this is the solution between the both. So this concept is known as dead peer detection. So we have some timer concept into this. Okay. Okay, what is the timer after? Let's consider the session is idle for the 15 minutes. So what is the timer for how long this session would be idle, and after that only we would send the DPD here. So what are those kind of concepts, so that we will discuss tomorrow. Okay. So today intention was what is the IP, what is the first NAT-T, then concept is what is keep alive. Is it good or bad? Okay, so it has both the scenarios. What is the solution? DPD is the solution. So about DPD again, we will discuss tomorrow in depth, and we'll see the practicals. Yes, guys, is this clear? Any doubt? Any questions, sir? Clear? Okay, Pawan. Fine. So just guys, try to finish all these things, the practical as well of the NAT-T, and then tomorrow we'll start with the DPD. So tomorrow I'll finish DPD and I'll try to find out some others, like 1 or 2 small topic, like one is PFS and 1 or 2 more small topics. So we'll finish it tomorrow and then we'll start with the GET. Okay. So guys, so shall I close the meeting? Then see you tomorrow. All clear? Okay, guys. Fine. Then see you tomorrow. Bye bye. Take care. Have a nice day. Thank you.